Now we will walk through creating a simple model with UDEC. Assuming you have installed UDEC 7, go to your Windows search bar and search for the UDEC 7 and choose UDEC 7 Geek, G-I-I-C. It's possible to run this example without a license. So if you've downloaded UDEC, a demo version, and you don't have a license, we can still walk through this example. If you run it without a license, you will see this warning screen just saying, hey, I didn't find a license. All you need to do is type C for continue, and we can carry on. So the first thing you will see is the model options. Here's where you can turn on creep or thermal or dynamics. We don't need any of those things for this example. So we can just use the default options and click OK. Now you can give a title for your project. We can call it sliding blocks. You can give a file name for the project and call it sliding blocks. If you want to change the directory that it's in, you can press on this little disk icon. But for now, I'll just use the default directory. So I click OK, and I've created a project. The project is essentially the container that holds data files and plots and save states so that you can navigate between these things within the project. So we basically now have this empty container with nothing in it. So the first thing we're going to do is build a block. So you can see that the way that this interface works is it's intended that you move from left to right, doing operations, building up the model, and then eventually running it. So if we start from the very left, we're going to choose build, and then we're going to choose block. So we'll start with a simple rectangle block. It goes from 0 to 20 in the X direction, 0 to 20 in the Y direction. And you can see here that the blocks in UDEC actually have rounded corners to allow them to more easily move past each other. And so there's a default rounding for the corners, and there's also a default minimum edge length. And these defaults are fine for this example. So we press OK, and we've got a 20 by 20 block. Here it's actually possible to add more points interactively or move the points that you've created, things like that, or edit the coordinates of the points that we've created. We don't need to do that in this case, so we just hit execute. And it will turn this drawing into actual commands. So as mentioned earlier, everything that we do here turns into commands, and you can see the commands listed here on the left. And you can see the block that we've created here on the right. So now we need to put some joints in here to divide this into smaller blocks. So again, moving from left to right, we start from build and we go to joints. So we can see that line is selected here. We're just going to make a joint that's a line. And so I could draw it here, but I want to be a bit more precise with my coordinates, so I can say input shape. And I can say I want my line to go from 0, 2 to 28. Click OK. So here's one fault or discontinuity that I've created. And again, I could now go and move these points around or edit them, but I'm happy with the way it is. So I say generate shape. Now I'm going to add a vertical line. So I can say input shape again. And this time I'm going to go from 5, 3 to 5, 20. Click OK. Now, if you're having trouble following along, or if the font is too small, this whole walkthrough is available as a download. So you could do this on your own time, or you could print it out and follow along while you're watching this video. So there's my vertical joint that I've just done, and I click Generate Shape. I will draw one more joint. This time we'll go from 5/12 to 20/18. Okay, and so what you can see here is we have two different joints at slightly different angles. So depending on what we choose as a friction angle, these things may or may not slide. So we're done with that. We say Generate Shape. One more other thing to note here is that it doesn't really matter if I go a little bit past the joint when I'm drawing a line. UDEC is smart enough to take care of that sort of dangling edge there. So if I hit Execute, I've now got my model that's composed of 4 blocks. And now is probably a good time to actually save this. So down in the bottom left here, there's a Save button. And I can save the state, and let's just call it Sliding 1. By default, the extension is .sav for save file. It's just warning me that I don't have a valid license, but I can just continue on. That's fine. Okay, so we've created our blocks. Now we need material properties. So again, moving from left to right, we'll skip the alter at the top here and we'll go to Material. And we choose Block Material. Here you can actually have multiple materials. So different blocks could have different material properties. They've given you one here. By default, I could create more. But for now, we can just edit the one that they've already given us here. So if I click on this user new one and I click edit, I could actually change its name. For the class, I can leave it blank. And for the name, I can choose just block. Now, these blocks are not deformable. They're perfectly rigid. So the only property they have associated with them is density. So I'm going to give them a density. In future tutorials, we'll show you how to make the blocks deformable, and then you need a Young's modulus and a Poisson's ratio and so on. But for these rigid blocks, you only need a density. So we can say, okay, we're done with setting the properties. Now we need to apply those properties to all of the blocks. So I can say set all. I can say execute. So you can see here that it's telling me block property, material 1, density 2000. Now we've assigned properties to the blocks. We need to assign properties to the joints. So we're still in the material selection here. And we go to joint material. In this case, there's no default material here, so we need to create one. So we'll just create one. And again, for the class, we can leave it blank. And for the name, we can call it joint. Here you can choose different types of joint models, but most of the time we're using this more Coulomb style joint model where you just give a cohesion and friction. So we'll just leave the default there. And the properties that we need are the shear stiffness. So we'll do 1.33 E9. We need a normal stiffness. We'll make that the same. And then we need a friction. We'll make that 20 degrees. You can fill in cohesion, dilation, tension as well. If you don't fill anything in here, it defaults to 0. So these are going to be relatively weak joints with a friction angle of 20 degrees and no cohesion. So I say, okay, I've defined the properties. And again, I need to assign them to the joints. I could assign different properties to different joints. In this case, I'm just going to choose set all. to assign the same properties to all the joints, and then press execute. And again, you can see the commands that have been created here. And one extra command here is telling you what the default properties are, because one of the things that happens in UDEC is the blocks can move relative to each other and new contacts can form. And so you need to somehow tell it what properties should be used when a new contact forms. And by default, it will just give it the properties of the joints that I've already created. Okay, moving from left to right across the top, I go to in situ, and what we're going to do first is fix the bottom block, fix the left-hand block, turn on gravity, and see what happens. And in theory, nothing should happen because two of those blocks are fixed and nothing's really going to move. And then we'll delete the left block and watch these things slide. But the first step is to fix the left block and the bottom block. So we go to in situ and we choose fix. Under range here, I could draw a rectangle to encompass the blocks that I want to fix. For this simple example, I can just do it block by block. So under range, I can choose single. And I can just click on this left block, click on the bottom block. You can see the commands being generated over here. And then I can click execute. All right, next step, we turn on gravity. So we go to settings, gravity. You can click on this little picture of the Earth to get the Earth's gravity. It's certainly possible to choose gravity that is different from that, but most of the time you will want the gravity of the Earth, and you want that to be acting vertically. So we hit execute. Now I have gravity, and we're ready to go. We've got our geometry, we've got our properties, we've got our boundary conditions, we've turned on gravity, and now all we need to do is solve. So we go to run, and we go to solve. And there are a bunch of options here, which we'll cover in future tutorials, but for now, you can just hit execute. Now, this is a very simple model with only 4 blocks in it. And so that reached an equilibrium state very, very quickly. You can actually see what it's doing by going up here and clicking on the console. And this sort of echoes all the commands that we've given so far and tells you some information about what's happening with respect to the cycling. In this case, it was so fast, we didn't even see it go by. It ran 93 cycles, and then it finished, and everything's at equilibrium. So if I go back to the record, now would be a good time to save this. I can say save, and let's call it sliding 2. And just for fun now, we can create a plot to see what happened. So up at the top here, there's a button for plot. I click on plot, and then I click on model. And here are all the things that I can plot. And I can give this plot a name, which is a good idea because you might have multiple plots, and it's good to have names to keep track of them all. And so common things that you might want to plot are at the top here. So blocks, very common. Displacements, very common, but I'll show you how to get to that another way. Again, here's a list of all the things you can plot. So let's pretend I wanted to plot a vector of displacement, so I can go here to vectors. I can choose displacement, double click on it, and choose OK. So now I've got a new plot showing the blocks and displacement vectors here. You can see the maximum displacement, 2.9 e minus 4. So there was not a lot of movement here. There's just a little bit of deformation on the joints as this thing settles under gravity. So now is the fun part. We're going to delete this left-hand block and see what happens. So we go to Alter over here at the top and choose Delete and Add. Again, for the range, we can choose Single. And we can just click on this left block. You can choose Execute. So now the left block is gone. So we're going to solve this. We go to Run. But in this case, we're actually not going to choose Solve because this particular case will not come to equilibrium. If you recall, the friction angle we set was 20 degrees. And one of these joints, the top one, is steeper than 20 degrees. So we expect this top block to slide and continue sliding forever. So it will never come to equilibrium. In this case, we need to specify some number of cycles, otherwise it will keep on running forever. So instead of Run Solve, we choose Run Cycle, give some number of cycles. So click on Cycles and enter 6,000. Click Execute. So in that case, you saw the calculation window flash up there, but it was still quite quick. It ran 6,000 cycles, and you can see that this top block is actually moved a little bit. If we go to our block plot, you can now see, hopefully, the arrows of the displacement, and the maximum displacement is now 0.67 meters. And this top block is clearly moving quite a lot. So we can save this. Let's call it sliding 3. Now, the fun part about this project setup is I can actually go back to a previous state, restore it, and then carry on with different properties. So let's go back to the stable state, sliding 2, just after we turned on gravity. Oh, it's giving me warnings about the license, but that's okay. It's very quick to rerun this. I'm going to start from this sliding 2 case, and we can choose Follow to essentially make a new branch and go down a different path. And so what we're going to do now is change the friction and see if we can get that bottom joint to slide. So if we go to Material, Joint Material, we specified this joint property, this joint material already. Let's make a new material, so I can just click on this joint and choose Clone. So now I've got a copy of that. Click on that and edit it. Change its name to Weak Joint. And now change the friction to 11 degrees. OK. Click Set All to apply that new joint properties to all of the joints, and then click Execute. Again, you can see the commands that were generated over here on the left side. And so again, we'll solve this thing, but we don't actually want to solve it because, actually, first of all, we need to delete that. Oh, we can solve it first. We'll solve it first to make sure everything is still stable, and then we'll delete that left block again. So let's do Run, Solve, and assuming we did everything correctly, it should be very quick. Say Execute, and we can save that. Let's call it sliding 4. Now we go and delete that left block again. So remember how we did that? Alter, delete and add. Single is still selected for the range, so I just click on that left block, choose execute. And now we'll do run, and we'll not choose solve, we'll choose cycle. We'll enter 6,000 cycles, and we'll choose execute. So if we go to our block plot, you can see that the top block has moved and the bottom block is now moving as well, because the friction angle is less than the angle of this bottom joint. And so that's basically it. We could save that state. We could call it sliding 5. The other thing you can do, which is useful when you have more complicated models, is rename these branches. So branch A and branch B is not very helpful. I can right-click on this branch A and rename it and call it strong. And right-click on branch B, call it weak. And so now you can see how we have these different paths for the model that we've constructed. So that's basically the end of this model. Now would be a good time to save the project itself. Remember, the project is the wrapper that holds these save states and these plots. So you can just go File, Save Project, and it will save everything. And next time I start this up, I will be back at this exact situation. For the next part of this tutorial, we're going to look at the GUI, which is all command-driven. And so one useful thing to do here is to actually export the commands that have been created in this Geek version that we can use in the GUI version. So if I go to File, and I go to Record, and I choose Export Record, it will export all of those commands in a data file. And so let's just call it sliding joints.dat, and choose save. That is the end of part 2.